Welcome to Fresh Concrete. This is one of a series of online talks produced through partnership between the Concrete Centre and the Building Centre. And it's to showcase some of the innovative uses and manufacture and types of concrete that are being developed. So my name is Elaine Toogood, I'm Head of Architecture at the Concrete Centre, and I have been delighted to have the opportunity and the challenge to help select the new concrete technologies featured in this series. The underlying theme that runs through all of these talks is innovation, and innovation that addresses climate change mitigation and the adaptation needs of the built environment today. So this session is on innovative concrete construction. Versatility of concrete is one of the reasons why it's endured as a means of construction over the centuries. Its evolution has been informed by the demands of the way we live or we want to live, but it's also influenced by innovation from other forms of technology. Now, there are currently very many ways in which concrete is used in construction, as I'm sure you're aware, different types of products and forms and framing systems and solutions, cast on site or pre-manufactured or a combination of the two. So for this series, we've chosen just two examples of very different approaches to methods of constructing in concrete, both of which bringing with them added benefits in terms of resource efficiency and carbon savings. And the two that we have chosen are de- and reconstructable modular concrete systems and 3D printed concrete. So I'm going to introduce you to the presenters in a second, but after each presentation, there will be time for a bit of Q&A, hopefully to be able to respond to some of your questions. So as we're going along, please do submit your questions via that Q&A button at the bottom of the screen. For the following presentation, I have the pleasure of introducing Natalie Wadley. I hope I'm saying your name right, Natalie, or you'll tell me if I did or not later on. She is Director of Changemaker 3D and is going to be sharing details about a revolutionary way of constructing using concrete, enabled by the developments in digital technology. And of course, what we're talking about there is 3D printed concrete. Now, digital technology is transforming much of the construction industry, and of course, concrete is no exception. Examples include AI, GPS to monitor and control the quality of manufacture and improve the logistics of delivery. There's automated 5-axis routers creating complex shapes in formwork, potentially replicating digitally scanned elements or designs, or augmented reality and virtual reality to understand and assess the design of formwork on site, for example. There's very many more. And of course, also 3D printing, such as 3D printing the molds or the concrete itself. And that is what you're going to hear much more about now. So over to you, Natalie, if you would like to share your screen. I will stop sharing. Very nice to see you.
Hello, everyone. Thank you for inviting me along today. Just going to set the screen up now and just let me know if we have any sharing challenges.
No, you're absolutely fine. We can see that it's just going to go to your... Brilliant. So over to you. Thank you very much. And take your time. Tell us what you want to share with us today. Thank you.
Okay, thank you. Well, following on from Elaine's introduction, I just would like to say thank you for giving us the time to talk about both Changemaker 3D and 3D construction printing. I'd just like to start by way of introduction to us as a company, as well as taking you through what we're doing with 3D construction printing in the UK, some detail around both the robotics and the material, because there's interest in the innovation of bringing those two component parts together, and also some use cases that we have across the rail and the water sector. But really, to start off with, we started the business with the vision that you can see on the screen, and it's about sustainability. So everything that we do with the technology with our clients is how can we leave that lighter footprint on our planet? How can we improve infrastructure for all? And how can we make sure that when we're using 3D construction printing, we're not just addressing productivity, but we're also considering carbon and the legacy within our communities through things like creating greener jobs and looking at digital skills. So we really have a holistic view to why we exist, why we get out of bed in the morning. And I just wanted to sort of set that scene for you. And really our kind of why is that we want to be part of the solution to addressing the climate crisis and very much the humanitarian crisis that we find ourselves in at the moment with pandemics and wars and challenges. So we recognise that there's a role for us to play, and not on our own, but really with our industry, delivery partners, supply chain and clients. And we believe that now is really the right time for a step change to introduce digital technologies like 3D construction printing in a way that the industry is now ready and able to look at adopting these as business as usual. So who are we? Well, we're a UK SME. My husband and I set the business up in 2017. I have a social value background and my husband has a printing background, and we came together not from construction, but to look at how we could be part of that construction solution. And we're building a market as well as a business, and that is through print-for-structure. Which is about creating that end-to-end 3D supply capability. We believe we can target 2% of the infrastructure space in the UK by making swaps from traditional construction, concrete methods into 3D construction printing. We as a company are representatives on the Global ISO Committee for Additive Manufacturing in Construction, and we really passionately understand that standards and standardization within our space, our technology, are absolutely key for unlocking this going forward. We've also been involved with leading the trialling of graphene enhanced materials, 3D materials, particularly the quick drying concretes, with a range of graphene suppliers in the UK to understand where we can innovate further. Our focus is on quick drying concrete materials that can be extruded out through printers, but that are both on-site and off-site robotics. And we are seeing a similar performance to a standard C40 concrete mix in the UK. So I'll just dive straight into the tech. I think the first thing to explain to you is that we as a company set up from a very bootstrap business. And so we realized early on that we weren't going to have the cash resource to jump straight in and build our own printers or develop our own materials. And so we took time to understand the global market, to really analyse who the players are, where those best athletes are, and so we can bring a diverse supply offer to the UK. And we've been spending a lot of our time over the last 3 or 4 years focusing on the SciB construction. They provide both a material and robots that are partially utilising ABB robotics. So the material science you can see here is based on their materials and their mortars. And just from a material point of view, it is a very quick setting process. It's dry within 5 minutes, and that presents challenges, because that's from a mixing perspective. And when you start adding in the water to the powder bags, to mixing the material right through to the extrusion process with the robot, so there's definitely it's a very fast process, and you have to be in terms of implementing that with skilled technicians who can understand how to get the best out of the material. It is load bearing in about an hour. So some of you may or may not have seen videos of printing, but it really does just layer up in front of you, and it's solid and setting within a very quick space of time. Its compressive strength at 28 days is typically about 35 newtons per metre squared. But what we're actually seeing through our own testing in the UK as well is that we're getting, you do get some early, between sort of 3 and 5 day good compressive strengths of anywhere between sort of 20 and 25 newtons as well. So you can look at some accelerated time savings there. You can see how it's comprised of a 70% non-Portland component and a 30% aggregate with a maximum 3 mil. So it's very fine. It's technically a mortar, but it kind of behaves, performs like a concrete. So there's sort of a slight play on whether it is, people refer to it as mortars or concretes, but it's more of a language thing. It's not a metallic, it's low chloride and sulfate content. So from our perspective as a sustainability driven business, we want to make sure that we're bringing materials into the process which are at this point in time the most environmentally friendly they can be. And the manufacturer data set points towards a 30% less CO2 than sort of a standard concrete mix as well. So these for us point us in the right direction of why we'd be wanting to integrate these types of materials. There is a lot of third-party testing that's already happened through the manufacturer, through UCAS accreditations and using Euro codes. And we ourselves as a business are already doing our own validation of those tests, whether that's on the material or whether it's on product development testing and validation with the likes of the BRE who are doing testing on our behalf. So the design life of the material is comparable to concrete, and therefore all of the assumptions are that it will be in excess of 50 years. And I'll talk to you a little bit more as we go through about case studies around in the water sector, particularly around where we've been applying the material. And then from a robotics perspective, you can see both pictures there. You've got a gantry option and a mobile option. We've focused a lot of our work up to this point on the mobile robot because we're really interested in not just the design principles, but also the construction steps and thinking about this entire process really differently. What can we do with an on-site offer versus an off-site offer, and what can those options do to construction programs, to safety, to the number of workforce that need to be on a site at any one time, the amount of craneage that may be reduced, for example, if we can print in situ. So there's a real set of good construction methodologies that we've been getting to grips with our clients as well. The print speeds itself, again, it has to be quick because we've got a quick drying material. So you're looking at about 0.5 meter a second of it laying down. And again, you can just see a little bit more about the fact that it's supported by 3 outriggers, and it can take a substantial force through one leg. So it has about a 3 meter print diameter in kind of like a donut shape that when we're doing the digital design modeling, we would be constantly cross-referencing that with, does this sit within the sphere of the print capability? And if it doesn't, it's not the end of the world. We just design to be more panelized or more modular, but where we can print to have one structure where we've got no joins, for example, then we're obviously playing to the strengths of the printer and the material. What do we do within that space as Changemaker 3D? Well, to the left of that screen, we have started off with the design, and we've started off with our clients to analyse where we can take standard temporary and permanent assets and whether we can redesign them into a 3D constructed design. And again, we can talk a little bit more about how we've been approaching that. And then the second aspect of what we offer is to build. And again, we're just in that scale up phase at the moment of being able to have printers ourselves and be able to roll those out on a regional basis across the UK. But the intention is that we will have a robust build offer with a variety of printers so that we can be printing both on-site and off-site. And then longer term, we're hearing from our clients and tier one partners that there's maintenance considerations. So we need to have a response to that as well. And also we recognise that because we're building a market, there is no skills framework. And that very much sits hand in hand with our social value objectives. So we are building out a 3D construction skills framework that will align to the ISO standard, that will hopefully integrate with existing apprenticeships in the UK, so that we do have a workforce of designers, technicians, material developers who understand print infrastructure in its broadest sense. I think we just want to talk about multi-capital benefits, because whilst we very much focus initially on the carbon, there really are a wide range of potential benefits. Why would you use the material? Why would you use the robots in this way? And I think the time savings are a key one to start with, so that it's depending on which asset, and it depends on whether you're doing on site or off site. So we don't have a one size fits all on time savings, but you can see anywhere between sort of a 10 and a 40 or 50% time saving, just because of the speed of the material, the speed that you can start utilizing the structure, and some of those steps that you can take out of the construction process. And also it really supports with labour efficiency. So what we're not doing is taking people out of jobs. What we are doing is recognising there's a skills gap, and that actually if we can automate some of the processes, either on site or off site, it means that the existing workforce can either be upskilled or reskilled, or they can be redeployed altogether into other areas of the programme, because we don't need as many people doing this particular activity. I think the cost savings, again, are asset specific, they're site specific, but what we are seeing is, again, anywhere between sort of 5% and 25-30% cost savings. And that's because of, again, sort of that the whole construction methodology we take, where you might be able to make efficiencies in taking steps out of the process, things like craneage, but also wherever possible we're not using rebar. We're designing out reinforcement wherever possible, and wherever design and safety standards allow us to, and also we're using material only where it's needed. So we can be very specific with where we do need additional depth of the wall. For example, the walls are typically 40 mils in thickness and about 12.5 mils in depth. So you can be very, very tailored, even within a particular asset, of where you're placing that material. And I think what we're seeing with safety enhancements is that with the use case you can see there of myself and Luke both hugging the first water chamber with lots of pride, that actually that was printed as an entire structure, one single unit, that meant that people didn't need to go back inside that structure to fit in shuttering and things like that. We were able to completely get the robot to do all of that work. And carbon reduction and social value, again, and I've talked a lot about these, but they really are able to play a key role in how the UK becomes net zero, and how the infrastructure sector can really lead in that. And we're seeing anywhere between 10 and 65-70% carbon reduction in the assets that we've been looking at. So I just wanted to come on to the use case that I've been talking about in the water sector. We are working with two flagship clients. United Utilities are one of the biggest water providers in the UK, and High Speed 2, who are the largest rail infrastructure programme in the UK and Europe. And we're working alongside several of their tier 1 delivery partners, from SCS Railway through to Costain and C2V. So within that, we've been able to look at a very standard water chamber, which you can see there. And we were given the opportunity to remodel that, and also to print a full-scale demonstration. And you can see some of those stats there that sort of back up what I've been saying to you about. One where you can see the robot, the printer head there, extruding round in a tool path that allows you to print in one structure. And again, you're able to then look at some of those efficiencies. I mean, that chamber itself was fully printed in about 3.5 hours. So again, it took about 7 days before we were prepared sort of safely crane it and things onto the demonstration site. But from a, if you can appreciate that, if that was printed in situ on site, you've got something that's sort of load bearing within an hour of being printed. So it's, we're really excited about the technology as much as we are about the impact that we believe we can start to make. And again, with High Speed 2, we've been looking at a really diverse range of use cases. We've started in the temporary works space because it's the right risk profile for adopting the technology. Really looking at anything from temporary retaining wall structures through to sort of parapets and anything and everything in between that. From a retaining wall perspective, there's lots of different applications, as many of you will appreciate when you look at temporary works requirements on site. So we've been able to really work closely with SCS JV, and see Andrew Duck's comment on that screen about how important it is to them to give the technologies like ours the opportunity to really really get to grips with having an impact in the sector. I think just a couple of things that I just want to summarise on where we are. So we are working through full-scale demonstrations in the sector at the moment, and we are testing and validating those with a view to being out on more sort of commercial processes towards the end of the year, where we're able to take on a pipeline of active work, live work for these clients. But what they've been really doing with us for the past year is de-risking this for themselves and for the industry. And we now are starting to see a really exciting pipeline that they're identifying that we can start to roll out within 2023. There are challenges. I think it's fair to say that standards and product acceptance are very much front and centre of all of our planning, and sort of industry challenges around things like PI insurance, and the barriers we're hitting there as an industry around the insurers not understanding or not being prepared to de-risk this technology with us and with our with other technology startups in this space. So it's not without challenge, but we're seeing a real momentum now with the likes of these clients that are really backing us as a business and what we stand for, but also backing the market that we're building. I think I'll just sum up there. Thank you for listening.
Thank you very much, Natalie. Sorry, my mute wouldn't come off for a moment. That's really excellent, and it's great to see the work that's been done to introduce this, to increase the use of this within the UK. We have got a few questions here.
Yeah.
And I will endeavour to go through to ask them for you. So a little bit about the mix of the concrete and the ability for it to be printed. So anything that you can say about the types of aggregates that are needed?
So we're not, as I say, we're working with Cybe Construction as the manufacturer on this, but our intention is that as the volume of requirement grows for the UK, that we will, with their agreement, we will move over to having the UK manufacturing the materials. So we're very keen to see where we can recycle aggregate going into there, when we've got more influence over that in the UK.
So, but presumably the aggregates, you can't use large aggregates within 3D printing.
It needs to be pretty fine. Yeah, it's that sort of 3 millimeter. It is a fine aggregate that we need. Yeah,
yeah. So, and so how far? Obviously, in other parts of the world, there's been quite a lot of development within this. And to bring to market within the UK, obviously there are, we've got our own set of sort of standards and regulations that need to be met, and how transferable some of those tests are to the UK market is a question. So there's one about sort of fire. Is there anything specific? Presumably fire testing has happened elsewhere to meet other countries' requirements, but what about within the UK market? Or
Yeah, so we're tackling that one. It's obviously a significant area for us in the UK, and we've started off with some fire safety testing with the BRE on some printed wall panels. That's at the moment, we're just in the sort of early stages of the fire testing, really just understanding what would happen within a 2-hour fire test. Can we at least understand that as a starting position, which is being client driven. We've got the design house from HS2, which includes Arup, sort of giving us a steer on the types of fire testing they'd like to see coming out of there. So we have started that journey, yes.
So developing it. The test hasn't happened in the UK yet, but I can't imagine that there's been any issues necessarily abroad. Otherwise,
no, there's nothing that we're particularly aware of, but we just wanted to make sure that we took ownership over some of that testing and validated it for ourselves.
Yeah, of course. So there's quite a lot of questions here. I think we've got quite a lot of engineers on the line. So it may be
which I am not. So we'll see how far we get.
Okay, excellent. So it may be that we can pick some of these questions up later on. Yeah. But there were some questions about the reinforcement, and you mentioned the opportunities to reduce steel reinforcement within structures, or the not needing it. Can you say a little bit more about that and tensile strength of the result?
So the tensile strength of the standard mortar at 28 days is it's about 4 newtons. So it's broadly comparable to again, it's the sort of C40 mixes, which is the baseline we've used. Admittedly, there are many different concrete types, so we've just sort of been tasked with comparing it to C40. In terms of whether or not you can put reinforcement in it, I think I saw a question around in the chat about, can you put reinforcement in? Yes, you absolutely can. You can design in for the use of rebar. There's also potential to look at reinforcement horizontally within the layers as well as vertically, in that kind of quite traditional sort of cage, reinforcing cage, where you might then pour in a quick self-leveling concrete or something into a void. So yeah, you can absolutely, and we are absolutely designing in those sorts of ways as well. But wherever possible, because of the way that you can approach the design, we're looking to design out reinforcement, and we're typically using a factor of 2 on all of our safety modelling.
Okay, thank you. Now I'll ask a question about the aggregates. Then there's some questions here about the cement that's used. I noticed on the slide you were saying it's a non-Portland based cement. Are you able to say a little bit more about that? And I know you've also mentioned graphene. Was graphene used in the work for that? I think these are examples, I think, of some other structures that have used graphene. Can you say a little bit more about those too?
So the manufacturers themselves have some sort of confidentialities around the material. So for the special mix, if you like, that goes into the quick drying aspect, which we're not privy to. But I do know that where it's more of a sort of a GGBS type equivalent to the Portland cement, that I do know. Yeah. And the other question around graphene, we didn't utilise graphene within the water chamber. We used the standard SIB mix. We were very happy with the performance of that, both from a sort of water permeability, through the walls of the chamber, and the strengths from the design principles. Where we are looking at graphene is more in the rail sector activity. And again, we're just taking very steady steps to understand and really test ourselves across different graphene providers, what can be utilised and where it's right to, because just because it might work doesn't mean we need to use it in everything. So where does it really add value? And we also want to make sure from a graphene point of view that we understand the sustainability impact, so how it is mined, how it is manufactured, so that we're not countering any carbon savings with perhaps adding something that's been quite carbon intensive. And we're working with graphene providers to fully understand that at the moment.
Yeah. Well, with all materials, it's important to understand their.
It really is. Yeah.
Concrete generally, and certainly within the UK, has a very good, it's a responsibly sourced to the highest standard. So you're absolutely right, that needs to be looked at. I think this one final question I'm going to ask is that with regards to the carbon statements that you've made there in the savings, are you able to, it was, I think you said a 30% saving of embodied carbon?
Is that on the material or in the product?
Well, I think that's the question. Somebody would
okay.
About what sort of baseline are you taking? So is that taken as a baseline if it was Portland cement today as baseline, or is it taken from something else? It's always tricky when you're making comparisons, isn't it?
Yeah. We've spent quite a lot of time really trying to get as transparent as we can on this, and both from the way that we are measuring the carbon from a product point of view, and also working with the manufacturers to support them actually to better, validate their own, the 30%, their claim of 30% on the material. We want to help them to validate that from a UK perspective as well. So there's work to be done there, but we are taking their stats based on kind of like a baseline of a C40 standard mix to go from. In terms of our own, where we're getting our figures from, with the water chamber or with a wall structure, for example, we're working with carbon advisors who are helping us to look at the whole life cycle of the product, through from construction, installation, operation, and decommissioning. And they've actually been, it's a company called Accordant Solutions who are supporting us too, and we've been building a 3D construction carbon calculator platform as well. So we want to really, as I say, just be as transparent as we can on that. And the baseline we've been using for the product is the traditional asset that we're analysing. So for example, if with the case of the water chamber, we took the traditional way that it was constructed, installed, in use and decommissioned, and then we ran a comparable with the number of days it took to print, the amount of material and so on, and broke it down in that way.
So thank you very much for the presentation, Natalie, and to everybody who has attended and the questions that you have asked. Please do look out for the other recordings in this Fresh Concrete series to find out about more innovation and development and a fresh approach to concrete with regards to not just the construction, but also in the use of concrete and also the development of the concrete itself. Thank you very much.